Hello again. Hope you're having great day here, and I'm super excited to be presenting our project before you. And just brace yourselves and let's start the ride now. The agenda for the day is we're just going to see a very high-level introduction about data science and deep learning, and we are going to introduce you model asset exchange, and we are going to show you how to wrap your own model and create it as a microservice in minutes. And then we are also going to introduce data asset exchange and end with the resources slide. So this is like, let's start from the basics. So what is data science? The goal of data science is to find a solution to your business problem. How we are going to do it? So we are going to take your business problem and convert it into a well-posed data science question. And then we are going to use our tools, mathematics, programming, and all the scientific methods to find answers to the questions that you came up before. And finally, we are going to sit, communicate the results, and see how it is actually impacting the business. So this is how we have split the definition of data science into 4 points for easy understanding. And now let's see, let's take a real world problem and try to see how we can fit into the definition we have seen before. Consider I have a company like XYZ, and I'm facing an unfavorable situation where my employees are quitting jobs frequently, and I'm incurring a huge loss because of it, because I need to recruit again and then I need to train them, which is expensive. So, and this problem is called employee attrition. So what I decided to do is, okay, let me just solve this in a data science way. My first step would be to call my data science team and hand over the business problem to them. Then they will take this business problem and convert into data science question. For example, what are the factors contributing to employee attrition? Is it age? Is it salary, or the position, or the qualification? What is causing employee attrition? And the second possible question is, given the current status of an employee, is it possible to predict whether they will stay or not? So these are the questions that might probably come up. Finally, we will analyze the data, explore, create a model, and then interpret the results and see its business impact. So this is how we are just fitting that definition to real world problem. That's a quick question for you. Let's say I provide the authorized data to my data science team. Do you think they can take this data directly and directly give it to the machine learning model and expect it to produce a trustworthy models for you? Exactly, right? So it's going to be a faulty model. It's garbage in and garbage out. So you need to go through a certain process, right? First, you will take the data, which is the data extraction phase, and then you get into data cleaning. In data cleaning, for example, you will see, okay, what are the data is actually required for you, and if there is any information missing, then you will try to fill in those values and do all those stuff. So those are the examples for data cleaning. Once you're done with that, you enter into data exploration phase. So in data exploration phase, you will create a lot of charts, graphs, and you will see how features are related to each other, and then enter into the model development phase. Here you will use your machine learning, deep learning, whatever algorithm that will work for your use case. And finally, we will enter into result interpretation phase. Although data scientists spend like 70 to 80% of their time till the data exploration phase, the most celebrated part is the model development. It's machine learning and deep learning, all the steps. And focus for the day is also the model development phase. And especially it's deep learning for today. So what is deep learning? Deep learning is machine learning with large, deep neural networks. On the left side, you can see, it got its inspiration from us, how we think, how we see, how we understand things that are happening around us. Those are the inspiration for, the artificial neural network that you are seeing on the right side. Like us, they also have neurons. Every single circle there, right side, they are called neurons. And to put it in a simple words, this is something I heard recently in one of the meetups, and I loved the one-liner. So the speaker was telling it's circles and lines interacting with each other, and it made it sounded so simple, and it kind of motivation for people to start with. So there are circles and lines interacting with each other, trying to understand your data, and create the prediction model for you. So deep learning is nothing but machine learning with large deep neural networks. This is a very simple one. The first layer is called the input, and the middle one is called the hidden layer, and the last is the output layer. And imagine like thousands hidden layers inside, and they form the large deep neural networks. So why is deep learning so popular? It's not something that has been introduced recently. It's been there for a long time now. But all of a sudden, it's becoming like super popular. Like, why? As you can see from the graph, and also, we have access to huge amount of data now. And also, we have, systems that can perform, the computation efficiently. So if you can see in the graph, as the amount of data increases, deep learning outperforms traditional machine learning by a significant, percent. And it's really good at supervised learning. So what is supervised learning? It's like, okay, let's take an example of a dog. You want to create a system that will detect whether the image is a dog. So you have to give the feature. If it has this kind of eyes, this kind of ears, then it's a dog. Here you are providing the feature. Also you are telling if it has these features, then it's a dog. So you are providing both input and the target. So that is called like supervised learning. You are feeding both the input and telling if it has this input, then this is the result. So deep learning is really good at supervised learning. And also it learns the important features. So you are feeding like thousands features, and not all the features are important. So it kind of learns what is important, and it tries to create a trustworthy model. Okay, I know it's a crazy question, but still, what is there in the picture? Okay, so how do you know it's a dog? Yeah, so exactly. So you have seen those dogs, and someone would have shown you this picture and taught you, okay, if it has these features, if it has this kind of ears, eyes, and the structure, and it's a dog. And you would have seen that again and again, and your mind would have recorded it, right? That's the basics for the neural networks. Even they do this. You are feeding the data, it is learning it. Okay, if it has these features, this thing, then this is what the prediction is. Then this is the dog. So this is just a slide to get, give you a sense of how neural networks actually learn stuff. And this particular problem is called object deduction. You are deducting what is there in the image. Let's say you are given a task of, creating an object deduction application. So the first thing you will do is you will quickly get in and then see what are the available object deduction model. Can you see the number of results? Like 560,000 results out there. And trust me, like every single day, something new comes up, like some improvement or some new models. How will you know like which one to start with? So the biggest question in your mind, probable question will be, if you are a developer, should I learn deep learning from scratch for creating this application? And if you are a data scientist, then, okay, how do you find which is the best model? There are like hundreds of models available. How do I know which one to start with? Even if I get the, pick up one of the models, how can you be so sure that it will run in one go, right? So this is a probable question that one might have in their mind. And let's say you have decided to go with the full development process. What will you do? And how model asset exchange is going to help you in the phase? And I'm handing it over to Karthik, and he's going to take you for the rest of the ride.
Thank you, Saishruthi, for setting up the stage, and thank you everyone for joining us this afternoon. So just by show of hands, how many here have worked with deep learning, whether they have tried it out or built an application or trained a model. Okay, so a lot of these points that I'm going to bring up will be really familiar to you because you would have probably gone through all of this process, right? So the first step involves finding a model. So the three key questions that you would ask is the model that you find, does it do what you need? Is it free to use? And is it performant enough? Like Saishruthi mentioned earlier, if you just search for object detection, there's going to be like a lot of models, but let's say even if you narrow it down to the top 10, you got other questions that you need to answer like this. Some of them may not be free to use, some of them may not be free to use commercially. There's always the questions of performance on a particular data set versus your data set, stuff like that. So it's not the easiest thing to just shortlist a model immediately. That's the first step. The next step you do is, let's say you narrowed down on a model. What about the code? These days, a lot of papers that get published also open source their code, which is a really good thing. But then again, there are multiple implementations, some by the author, some by other developers and other companies. There's also the issue of research versus production code. It may work well to reproduce the results of the paper, but again, is it performant enough for you and your web application or any application that you're working on? And there's also the legal issue of code licenses and the other legal hurdles, right? The third point is, once you have let's say you even narrow down the code and the paper, the next question is training the model. So there are models that are available with pre-trained weights that span frameworks. It can be TensorFlow, PyTorch, Keras, Onyx, stuff like that. So what is the framework that sits with your pipeline or sits with the rest of your code base? And what are the frameworks that your developers or you are comfortable using? So that is another choice, conscious choice that you need to make both as a developer or as a data scientist. And let's say even if it's pre-trained, does it do what you need to do? So it may be pre-trained on a specific data set, which may again have issues of licensing. It may have personally identifiable data, stuff like that. Or you may have proprietary data that you need to retrain the model on, right? And the last step is, hopefully if you're gone through all of this, the last step is to actually make an application that can consume this model, right? So you need to have inference code. If you've worked with TensorFlow graphs, you would know that the training graph is different from the inference graph, so you need to have a specific inference code. You need to package all of that in a meaningful way, and you need to deploy all of this in a scalable fashion, right? So again, getting back to the developer versus data scientist dilemma, so you can see the first two or three blocks are more data science heavy, and the third and fourth are more software engineering heavy. But it's a spectrum, so you need to be doing all of that. And as you can see, it requires a lot of time, expertise, and resources. It's not an easy problem, it's a hard problem. And our answer to this problem is MAX. So MAX, or Model Asset Exchange, is a collection of open source deep learning models that has gone through this rigorous process that I mentioned earlier. That's our website. Feel free to check it out as I speak. So what is MAX? So it's one place for all state-of-the-art open source deep learning models. We have a lot of models. Right now we have around 30 plus models covering multiple domains. So for computer vision, we have object detection, image segmentation, image classification, stuff like that. For natural language processing, we have models ranging from text summarization, toxic comment classification, named entity recognition, and we also have a few audio models. All the code has been tested and vetted for IP, so all of the code is, the licenses are fine. It's all licensed under Apache 2.0, so it's reusable and also reusable commercially. So you can get started building a commercial application without worrying about legal ramifications. And we also have, while all the models on the Model Asset Exchange are deployable in the sense that they perform inference, we also have a lot of our models trainable locally as well as on the cloud. So that was what the project is, and let's see how we built it behind the scenes. So this is, again, going back to the process. We find a state-of-the-art model. We validate all the licenses. We perform model health check. By model health check, I mean we make sure that the core and the model weights and the data set not just replicate the paper itself, but also make sure that the code is in a fashion that can be deployed scalably. And we then wrap all these models and provide a REST API. That's the core of the microservice here. And we also publish them as images on Docker Hub so that you can just pull all of these models with just one line of code if you have Docker installed. So, and lastly, as Saishruthi said, there are models that are coming up every day. So if we find a better model or if we find some inherent performance issues and stuff like that, we keep improving on these models and we have continuous integration. So all our Docker images are labeled with version numbers, and as and when we find a better model that does something better, we update it there as well. So all of this top half is what I was talking about. So we have all of these bundled as a deployable asset on Model Asset Exchange. But what do you as a user or at the application see is a couple of endpoints, inference and metadata. And we also have Swagger as the UI that comes out of the box. So this is the core REST API microservice that I was talking about. So you send a post request with the input to the model. So let's say if it's an object detection model, you would send an image as a post, and it would respond with the corresponding labels and the boxes. And likewise, you can also send a GET request to get metadata and other couple of APIs that we have exposed. This is built using Flask. So this is how the Swagger UI looks, and it comes inbuilt with all the models. So as you can see, you have the post and the GET for the metadata as well as the model. But I can show it to you right now so that it's so this is the model landing page. Oops, not sure. Yeah. So this is the model landing page. As you can see, we have the API here. And this is the UI I was talking about. So let's say one of the APIs that we have is custom API that we have is model labels. So if you run this, you can see the 80 classes that this particular model supports. It was trained on the COCO dataset, so it has 80 classes. And this gives you some metadata information about the model itself. So the architecture, the data, the description, and the license information. And finally, this is the one that you would be using to predict. So I have an image of a dog here. This is a tunable parameter for the confidence interval. So right now the model, if it's 70% sure that there's a dog in the image, it's going to predict it's a dog. So it's 98% sure that there is a dog in the image, and these are the coordinates for the boxes itself. Right? So let me go back to the presentation. Right. So that was just a quick, to show the UI, the Swagger UI that comes bundled with it. This is a code that does the same thing. So it uses the requests library of Python. You can send in a simple post request and get the response JSON. In this case, the response looks like this. It's a different image. So there's two objects in the image, and those are the bounding box coordinates. So that's a couple of ways you can consume the model. A third way that you can consume the model or use it as part of your framework is a web application. So a lot of our Max models also come bundled with web applications that are built on top of this REST API. So it has a more intuitive web UI. It has a visualization component to it as well. So I can show you quickly a web application as well. Right. So this is a wrapper. Oh, so sorry. So I just submitted an image, and this is like a web application that's built on top. So it essentially sends the post request and gets the JSON and just visualizes it. It also has a couple of filters here. If you had more objects, you could filter based on objects. So all of this is open source as well and available on GitHub. I'm going back to this slide here. Right. So these are just 3 forms of consumption that I showed. We also have all the models, a few of the models as Node-RED flow. So if you're interested in IoT devices that use Node-RED, we also have NPM packages for them, as well as we have a few of the models released on CodePen as well. So that's great. So we have around 30 models covering possibly all major domains, but there's still a case that you might have to wrap your own model. So there could be a couple of reasons why you would want to do that. Let's say you're already working on a project, or you're already, through a couple of steps in the whole process. You found a model, you found a code, you wrote your own code in some case, and you want to incorporate this kind of framework into your model. So that's one reason why you would want to do that. The other reason is, let's say you're working with proprietary models or proprietary data, and you want it to be in-house entirely. So that's another reason why you would want to do that. And for that particular use case where you would want to serve your own model as a microservice, we have also open source 2 tools, Max Framework and Max Skeleton. This is the whole process that we follow to publish all the models. So if you would like to follow a similar process, we have also open sourced both the framework and the skeleton. So I'll just quickly summarize both of them and point you to the right resources if you want to wrap your own models. So the Max framework is a pip installable Python library. It's basically a wrapper around Flask. That's how all our Max models are served. And it abstracts out all the functions into a couple of major APIs, and that's the link for the Max framework. The Max skeleton is more like a template or boilerplate code. It incorporates Max framework inside it, and all you need to do is just click the use template button on GitHub, and you can get started with all the files. It has a Docker file. It has the core Python files required for model serving, and it also invokes the Max framework. So all the abstract classes have the scaffolding there, and all you need to do is just override a couple of classes. So this is the Max framework. So for example, for the core model itself, you would have functions like preprocess, postprocess, and predict. So this is the base class, and when you would invoke this into your pipeline, let's say your preprocessing involves cropping an image, so that would go in the preprocess block, and the predict function is calling a specific tensor in your graph, and the postprocess itself might be converting the coordinates from an absolute scale to a relative scale, stuff like that. And that is the Max framework, and the Max skeleton itself is, like I said, a GitHub template. So if you just go to use this template, it's going to fork this repository for you, and then you can get started with wrapping your own Max model or your own model in a Max fashion. A few requirements that we have when you do this process are listed here. So you need Docker, the favorite IDE or editor of your choice. We upload all the pre-trained model weights on cloud object storage or some form of cloud so that it's reliable. You list all your packages and requirements. That's the standard practice. And you obviously have your input and output pre-processing codes. So with this, I'll hand it over to Saishruthi, who will show you a small demo, a small hello world demo, if you will, of wrapping your own Max model. Thank you.
Yes. So this is something we are so excited to present today, how to wrap your own model and create your own microservice. So these are some of the steps. These are the steps actually. The first one, log into a GitHub, and then we have the template ready for you. You just have to use the template. And the second one is you need to update your Docker file that we have there. And the third one, you need to update the REST API and model metadata. And you need to have in handy what are the packages that are required to run your model. For example, if it's a TensorFlow-based model, if it's a Keras-based model, if you want NumPy package, what are the packages you are required? So that you need to have that handy and update the model metadata and then update the scripts. As like Karthik was showing you, the pre-processing, post-processing, and prediction step, have all the scripts ready. And then finally, you will build the Docker image and run it. So these are the steps that you need to follow in wrapping up your own model. And we're going to have a quick demo here. So the use case that we took, it's the the basic of the deep learning. Whenever you start, you directly start with the MNIST dataset. So the goal here is to classify handwritten digits. You can see, this is how the input will be, and it will predict what is the input. So the dataset is called MNIST dataset, and that's a link where you can find the solution for this. And let's see how it goes. And we are going to see all the steps that we saw on the previous slide live here. First, get into the Max skeleton, and then click on Use this template, and provide a name for your repository. So I'm just giving some MNIST repo, and create the repository. By then, you should be having all the scripts ready to wrap your own model and create as a microservice here. This is the Max skeleton that Karthik was showing you. And now clone the repository. I think it's hidden. So, and just get into your clone repo. And now you need to start, either use any of the Python IDE or Coda text editors to start editing all the scripts that are required. I'm just using PyCharm here. And the first step, update the Docker file. So in Docker file, you need to have two things handy. The first one, you should be having your model file, that is a trained model, in one of the public storage that is downloadable. So I'm just updating the path to it. And then I have my model file name here. So that will go into the model file, and the model bucket is the location where I have. And since I have it as a file, I'm just removing the archive step here. And the third step is to update your the model file hash value. Just create I'm just creating MD5 hash value here, and then just update in MD5 sum.txt. And we are done with the first step. And the next one is I'm updating all the required packages. So click on requirements.txt and update all the required packages, NumPy, Pillow, Keras, TensorFlow, whatever you want. And the third step is updating your model and API, REST API metadata. Click on config.py script and update your API title. Here I'm just updating this as Max MNIST, and provide a simple description for it. Here I'm giving it as classified digits and version 0.1. And then in model name, provide the model file name. Here I have it as model structure.h5, then I'm just providing the model name. And now get into core model.py and update the model related metadata, by which I mean what is the name of the model, what is the ID, what does your model do. Here it classified digits, and what's the source, what is the license for your model, and I'm just giving this a deployable model. You can update this as per your wish. And the next step is updating, importing all the modules that are required. For this, get into the same core model.py script, and then update all the required modules, and then import all the required modules. And the next step will be, you need to now load the model. So I already have trained the model. Now I'm just loading my trained model. And the next step is update the pre-processing code. Let's say my input is an image, right? Now I need to convert my image into NumPy array. So that code, that pre-processing code will get into the pre-process function. And the next one, now I have loaded the model, I need to predict. So the model predict function will get into this predict the function below this. And the next one is decide what are the outputs you need. Here I need two outputs. One is I need the prediction and I need probability of my prediction. So get into API predict script and then update the label prediction path. Here I'm updating with two. One is the prediction, which is an integer type. My model can predict from digit 0 to 9. So that will get in here. And finally, update your post-processing. So the prediction will generate the digit and also the probability of the prediction. Now I need to return those. So update, so this is in the form of list. So I need to know what format my model needs. So I'm just creating a dictionary inside the list and I'm updating the value. So you can see the, now I have my prediction and my probability. So till now we have updated pre-processing, post-processing and the prediction step. And finally, I'm extracting the result and then passing it to the required variable here, result prediction. So what we have done is we have updated the Docker file, we updated the requirements, we updated pre-processing, post-processing, and the prediction step. We loaded the model, and we are done. Now we need to build the Docker image. Just build the model, and then run your model. So now I'm just running the model here. You can see it starts in localhost port 5000. Just get in, and you can see your model microservice here. Max MNIST, and just choose your own input. And here I'm just giving the digit 8, and click on execute. You can see the prediction 8, and the probability. So this is how you need to wrap your own model and create create your own model microservice using Max Skeleton and framework. Now I'm handing over to Gabriela for introducing data asset exchange.
Thank you, Saishruthi. This is awesome. They created all this. This is very cool. So you should totally check this out. And in the repo, the instructions, they are all written so you can follow the steps. So this is very awesome. Thank you very much. So cool. So just to finalize here, when we were doing this whole process, the model asset exchange, we've been working on this for the past year. As they mentioned, we have more than 30 models. This one that we showed today was the deployable side of things, but we have the trainable ones. And we are going to be releasing more trainable models. But one pain point that we had when we were training models and doing the model asset exchange was about data. So there are a bunch of data out there in the internet that you can find. But the license is an issue, so you don't know if you can use the data in your setting, in your enterprise setting, because legal issues, right? So we came up with the data asset exchange, and the idea is to solve this issue, or at least to help with this issue. So all the data that is out there went through several processes. So first of all, they are all data that was curated, and we go through the legal process, so you can use without worrying about the license. The license that we use, we try to be CDLA, so you can check more about the CDLA license. So it's the Community Data License Agreement by the Linux Foundation. So all these are good for you to use to train a model to do any machine learning that you want. It's a very recent project. It's been, we released last month, I would say. And we'll have notebooks that come with this data, so you can try using the notebooks, and all the metadata. They are standard, so they are all in a standard format with metadata and information about the data. So as I mentioned, you can use, it's a complement to the model asset exchange. And and so check this out, Data Exchange, IBM Biz /Data Exchange. And these are some very good resources. if you are getting started with the model asset exchange, I would totally recommend the third URL. And these are several URLs that we showed through the presentation. Some of our social network and our Twitter handle. So thank you all. Thank you very much for doing this awesome work and for being here with me. And congratulations. Thank you all.
Okay, we've got about a little over 5 minutes for questions. I'm here and Michael's in the back. So if you have a question, raise your hand and one of us will accommodate you, depending on what side of the room you're on.
I suppose all the goodness of fit tests are the client's responsibility, right? You don't have any tools for goodness of fit test, how well the model actually fits the data?
So for all the standard models that we presented, the one check we do is, does it match the metrics that's mentioned in the research paper that we took it from? So is that what you were alluding to? Oh, so we try to match the metrics that are claimed in the research paper when we get the code. So all the models that you see here and the citations that you see from the paper that they came from, they meet all the metrics that are quoted in the paper. So let's say it has an accuracy of 95% on the paper. You can be assured that the code also has 95% accuracy on that data set. So that's one. Is that what you were alluding to?
That's kind of what I'm asking for, but no goodness of fit. All goodness of fit test has to be done on the data itself to see how well it fits. You can't go to a paper. That may be a theoretical maximum that you get from a paper, but that doesn't mean you'll have what you experience or what you'll have at the end of the model.
Right. So most papers share their empirical results. All we do is make sure we match at least that as a minimum performance threshold.
Not really.
I think you were saying more like goodness of fit when you have your data, and then you are trying to see how it fits your model. And yeah, this would go with more on the trainable side, I would say. And I'm not 100% sure how we do that in the deep learning side, but I understand you because I'm a statistician, so we do goodness of fit all the time. But yeah, I think it's more on the trainable side, less on the deployable ones. We follow the research paper or whatever we have on the open source side. So we can talk more about that, and I can explain a little bit more on the trainable side of things. Any other question? Oh, we have to.
So, I mean, I think it's great that you guys are providing these Docker containers and, you can just run, get it from the hub and run them. Like, it's just out of the goodness of, like what do you guys get out of this?
Well, I know everybody have the same question when you are contributing to open source. So like, what is the revenue? Why are you doing this? It's open source. You are not selling anything. So it goes around why companies contribute to open source, why they pay someone to contribute to open source. So it's around mind sharing. So we contribute to the projects as well. Like we work when designing. So let's say we want to do something internally, but we don't have the tool. So we contribute and make that happen in the open source so we can reuse. So it's like a two-way thing. Yeah. Yeah, but that's a very good question, and I get asked all the time why and how. Like, why do you do open source, and then like how the company benefit from that? You're not selling anything. There is no revenue. So I think we had.
Hi, thank you so much. This was really, really cool. Thank you for putting everything out there. And I guess my question is more general, less technical. What's next, other than obviously, updating when something new or better comes out, and sharing more and more data and more domains? That's awesome that you can have like all in one place. yeah, what's next for the project?
So I can get, and then you can take a little about the training piece. But like every few months, we release a new set of models. So like last week, we released 3 new models, more focus on NLP. So we keep releasing new models and use cases around it and improving what we have. From the DAX, the Data Asset Exchange, it's the same thing. Every week, we are trying to get more data that is under the CDLA license when possible, or some friendly license. And then we are doing the training piece, the trainable one, which
yeah. So I would say that's our next big thing. So we are releasing a lot of trainable models, and we want to make sure, we are bringing a lot of hyperparameter tuning. It's not just trainable. So how can people customize it? Like we are bringing a lot of metric evaluations there, and then increase different ways of consumption of the model. For example, we have just gotten OpenShift, and we have CodePens. We have Node-RED, which we introduced recently. So we are increasing, the ways of consuming the model. So I think those are the next 2 big things.
And because I'm our person, we also have, it's not out there, but it's kind of like our side project. We are using R to consume the model. So the idea is to open as much as we can to all platforms, languages, and whatever.
Awesome. Follow-up question. How do you decide what models to focus on? Like the 3 NLP models, for example. How did you come to the decision of the community wants this at this time?
So this project is just about a year old, so we are just building up a standard deck of models. So we covered a lot of vision models, and we see wherever there are gaps, right? So we also go to some meetups, we get feedback from people as well. So let's say we had a lot of vision models, but not so much for NLP. That's the next step that we did. So we added a few more NLP models. And likewise, we also see metrics like which model is being used a lot and what other models would people like if they use this model likewise. So there we also focus on increasing the consumption channel. So object detector is one of our most popular models. So we have like almost 5 or 6 modes of consumption because people want it in different kind of applications, whether it's web apps or IoT apps or,
Okay.
yeah, different channels.
We have time for one more question here, and then we're done.
My question is about what limitations are there on the form of data that you can send to the system? We've seen basically only image files being loaded. Are there limitations on that? Does it have to be a file that you put in? Can there be decision points in the model where the model requests other data?
So that's a good question. This is just one model, like you said. So we have, for different models, we have different forms of inputs. For vision models, it's mostly an image, a file inject, if you would. But for other models, it accepts JSON directly, so you can have it in memory, mostly for the text models and all the other NLP-related models. And as for the other question that you asked, if you mean like, does the internal graph require a different kind of file? As of now, we're not exposing any internal graph related internals to the end user. It's just the input and the output layers that we expose.
Okay, I think that does it. So thank you for coming. We ran over a little bit, but great presentation. Thank you to our